is accelerate your AI/ML initiatives and deliver business value quickly by implementing practical and innovative approaches. That's a bit of a mouthful, I should say. I mean, maybe we should have used something like ChatGPT or something like that to make the title really crisp, but we didn't do it. But with the release of ChatGPT late last year, the interest level on AI has just grown exponentially. You will all agree with me that, however, that not all applications need large language models and generative AI and ChatGPT and things like that. So there's still a large need for what I actually call as good old-fashioned data science. Using just classical AI and ML and everything else. So just let me give you an example, right? We work with a customer here in Australia called Pacific National. What they do is they move cargo in trains, and they use high-speed cameras to monitor the conditions of the wheel sets. So they needed like a data analysis platform to assess the data generated and provide new insights. So what we did was we built a solution for them. We used statistical regression model to create league tables and report using Microsoft Azure and Databricks. We looked at the we used the data to analyze things like the wear and tear of the wheels, and things like the worst performing wagons and all those kind of things. This is what I actually call as good old-fashioned data science. And so in this talk today, what we'll do is we'll talk about how you can actually accelerate your AI and ML initiatives and deliver the business value really quick for our customers. Ladies and gentlemen, my name is Mahesh Krishnan. I work as the CTO here in Fujitsu, Australia. I'm based out of Melbourne. And one of the key things that I focus on here in my job is adoption of AI, not only for within Fujitsu, but also for our customers. And I also have with me today, Peter Kilroy. Peter.
Hi, thanks, Mahesh. My name's Peter Kilroy. I'm a principal consultant with Fujitsu Data and AI, specializing in data science and good old-fashioned data science. I'm very grateful today to have this opportunity to share our experiences with you all. I've got a numerical background, and I've been lucky enough to work with some amazing customers solving problems, delivering solutions across many different industries such as healthcare, energy, retail, logistics, manufacturing, and even the space industry. So fortunately, the rise of AI and data-driven decision-making has aligned very nicely with my skill set. So thank you very much, Mahesh.
Thanks, Peter. So what are we going to be talking about today? Well, one of the things is, like, I said earlier, everyone's talking about AI now. Everyone wants to do it, but only a handful of people are doing it. So let's talk about, see why that's the case. So let's look at the key challenges for AI adoption as a whole. And then we'll also talk about the process behind delivering AI models, what we use. We'll also talk about the approaches that we are taking in terms of rapid deployment of AI models. We'll finish up with talking about automation of ML process as well. We'll talk about auto ML, and finally we'll wrap up with some of the key takeaways for you. Now for the good news, right? This is an exciting time to be in the field of AI, as you all attest to that. It's predicted, a lot of analysts basically say that by 2026, the market for AI will grow to about $300 billion. It's about 3 times what it is now. And even that, a lot of analysts say is conservative, particularly with the growth of things like generative AI and LLMs in the last couple of years. A lot of people predict that that's $300 billion is conservative, and that the growth is going to be a lot bigger than that. And if you look at AI growth itself, it is not specific to any industry as a whole. You look at things like financial, there's a lot of growth in there. Public sector, there's a lot of growth in there. And even it's not restricted to any geographical location. Worldwide, we're seeing a big boom in the AI market itself. And of course, everyone wants a piece of that $300 billion pie, I guess. And so if you're a system integrator or a vendor, you want to ensure that you're helping your customers with AI and not miss out on losing that market share. If you are developing things internally, again, you don't want to miss out by not using AI, right? You don't want the competition to get ahead. So what's stopping us? What are the challenges in this specific area? So there are probably a number of challenges, but I think there are key challenges that we've actually identified, and I'll go through them one by one. The first one is around the long delivery times it actually takes us to deliver AI solutions. and that basically leads to decreased customer interest. So the main reason for this is like, everyone is saying like, let's actually start testing AI solutions with the simple proof of concept, and that's fine. And a lot of people end up testing the technology and not a business solution, I guess. That's one thing. But more importantly, the barrier of entry into AI is still very, very high for a lot of people. Because we work a lot in AI and data science and things like that, we actually don't see it. But only 19% of companies who are interested in AI have been able to get onto, to use AI in production, which is a staggeringly low number in terms of interest level and being able to get into it. So the barrier of entry is very, very high for a lot of these people because they don't know really where to get started. They don't know what infrastructure to run their AI workloads on. What are the tools and that they need to use? How do they get started? How do they work on the data? All these kind of things is holding a lot of people back. That's the first one. The second one is around the skill shortage itself. There's a huge gap between demand and supply right now. And so, skill shortage remains one of the biggest barriers in my mind. I'm not sure whether you've been following, but Netflix was in the news last month because they had a listing for an AI product manager role with a staggering $1.4 million as an annual salary, right? Now, that could be like more like an exception to the rule. But one of the articles in Wall Street Journal also called out that a lot of people aren't afraid to kind of like, some of these salaries in some places are edging to the seven-figure mark. And lots of companies on average, I think a lot of people, particularly in the US and things like that, they're not afraid to pay people, like somewhere in the mid six-figure salaries and then add things like bonuses and stock options and things like that. And they start to edge towards a very, very high salary. Not a lot of people can actually afford to pay that. And look, in fact, one of the strategies a lot of companies are adopting is acquisition of AI companies, not necessarily for the IP that they produce, but just for the talent that they actually have. And so, look, companies have also found that you just cannot hire your way out of these shortages. If you're a Microsoft or a Google or Facebook and some of these big companies, you have the ability to attract and retain this talent. But for a lot of other companies, it's going to be a problem. The third barrier that we actually see in terms of adoption is around unclear end state in mind. So what do I mean by that? Look, a lot of companies actually start with a proof of concept, right? But without any clear plan on how they plan to scale this in production. So they don't have very clear metrics in terms of what success looks like. And on top of that, there are a whole bunch of things that they need to think about when they start to scale this in production, which they're not doing. Things around governance of things like AI, how would bias in the data, ethical aspects of AI. They don't have a clear understanding of a lot of these things. What about model drift? Are they thinking about it? What happens when the original model that they've trained the data in is no longer applicable and you need to retrain the data, retrain the model? A lot of people aren't thinking about this, right? I mean, like one of the main things that they need is a really, really robust model in delivering AI. Let's get it right. And delivering AI is hard, right? And so Peter will talk about the model that we actually use or the process that we actually use to train AI models. Peter?
Hi, yep,
I hope
thanks,
the slide
Mahesh.
switched over.
Yep, sorry, a little bit of lag. Yeah, thanks. So the methodology for delivering AI or data science models. So Fujitsu originally employed the CRISP-DM methodology that some of you may be familiar with. That's the cross-industry standard for processing for data mining. So for data analytics projects, this was very suitable. It was developed by a consortium of experts and organizations, including Teradata, IBM, Daimler Chrysler, and some others. It was developed as a framework to provide a structured and systematic approach to data mining projects. The goal was to address the challenges of managing and executing data mining projects effectively through a standard approach and methodology. Now, Microsoft's team data science process draws inspiration from the CRISP-DM and has evolved to guide data science projects through their entire life cycle. It provides a systematic approach. It facilitates collaboration, repeatability, and best practices, ensuring that your data science projects yield reliable and impactful results. I guess one of the key strengths of the team data science project is the fact that it's very adaptable to various projects and industries, and we've been successful in deploying it. It provides a standardized structure, and yet it allows customization to adapt to specific needs. Importantly, the approach can scale up to support whole teams, and it can also be scaled down to support smaller teams where you might have, even a single data scientist taking responsibility for all of the different phases. So just to run you through it, there are, I guess, 4 main phases to the TDSP framework, and it's iterative. Each phase can jump from one to another and flexible, allowing the teams to adapt and facilitate communication. So the first phase, and probably the key phase, as many of you will be familiar with, is the business understanding. And for a data scientist, this is in many ways the hardest as well, because the project must begin with understanding a business problem, a clearly defined business problem or opportunity at hand. And the team would collaborate with stakeholders to define clear objectives, the requirements, the success criteria, and the data to support the data science project. So this phase is imperative to align the technical efforts with the business goals, making sure that the project is measurable and will deliver actionable insights. The next phase is where really the rubber hits the road for the data scientist, which is the data acquisition and understanding. Data is collected from the various sources. The team explores, cleans, pre-processes the data to ensure it's of sufficient quality and suitability to address the business problem. And understanding the data's statistical characteristics and relationships is absolutely crucial for effective modeling. I note that feature engineering is on the modeling side. Feature engineering is, I would say, where that arrow is in between modeling and data acquisition and understanding. It's where the art of the data scientist, to my mind, lies. It's the process of taking your raw data, your process data, and basically fitting it and adapting it towards the business process. So that really is key. The next phase is the modeling, where the team selects the appropriate algorithms, it creates and trains the machine learning models, and basically evaluates their performance against testing data. Multiple approaches are explored to identify the best performing model for the given problem, and you tune your hyperparameters and look at your ensemble modeling in this phase. It's kind of the fun phase. Finally, after actually identifying a candidate model, we deploy the model into a production environment for real-world use. This involves integrating the model into the existing infrastructure, creating the necessary APIs, and ensuring the model functions correctly in the target environment. Deployment strategies are devised to maintain model performance and reliability. And of course, we need to keep track of the model, looking out for, as Mahesh mentioned, model drift, conceptual drift, data drift, all of these kind of things. So that summarizes the process that we use at Fujitsu. Thanks, Mahesh.
All right, thanks, Peter. I hope we have the slides switched over. Okay, well, look, what I wanted to do is I want to talk about a use case of AI in action. We work with this company in Europe for the inspection of wind turbine blades, and I'm not sure whether anyone's actually seen any of these wind turbine blades. They're actually huge. They're about 75 meters long, and in terms of real world example, I mean, if you're looking at a cricket ground, that's about half the size of the oval itself, right? That's how big they are. And this company produces about 5,000 of these blades every year, and typically it takes a person about 6 hours to inspect the blade. Someone who's highly skilled, who can actually inspect the blade, it takes them about 6 hours to inspect the blade. And they can have multiple defects in these blades, things like fiberglass wrinkling during the production process. And what these things will actually do is they can have like catastrophic effect if like the blade crashes during operation. Think of it like this literally crash and burn kind of thing. Huge cost to actually repair them, fix it, and all those kind of things, right? Now, what Fujitsu was tasked to do is to come up with a way of using AI and machine learning to inspect these blades for any production defects. So once we've actually completed this project, we were able to reduce the amount of time it actually takes by about 80%. So that's a big savings in terms of effort. And if you multiply that by 5,000 blades in a year, just basic math, it kind of like comes to about 32,000 person hours that was actually saved per year. That's actually a significant cost savings, right? And it also reduced the production lead times, because you could actually do this thing quicker. Obviously, the other thing was like you also didn't need highly skilled workers to do the job anymore. Any creeping in of any human errors during the inspection process, all of those things were actually eliminated. Now, as I said earlier, right, one of the key things that businesses want is like they want to see value now. They don't want to wait like for a year for something like that to happen. So we delivered this project in weeks, not in months. So, for that, how did we do it? I mean, we did follow the TDSP process, and it helped that, we were able to define the clear business problem and goal. The goal was to basically reduce the blade inspection time and, dependence on a skilled resource. So that worked really well, and and also to improve the quality of the inspection. So all of those things, and from a safety and efficiency perspective, right? So we had all these kind of like goals that we had in mind that we were able to affect, that we were able to work on. Now, how did we actually do this in a short time? I mean, of course, you can talk about things like TDSP process, or we also used agile delivery methods, right, which is nothing new in itself. But more importantly, the way that we were able to deliver things quickly was by tapping into a pre-integrated AI framework. So what does that mean? What does a pre-integrated AI framework means? Look, I did say earlier that the barrier of entry for a lot of organizations is quite high because they don't even know where to get started. What this pre-integrated AI framework does is it puts a lot of those components that you need to work on an AI solution together, and even sets it up in an environment, on an infrastructure that can actually run complex AI workloads. So in this case, we've basically taken out all vendor names and product names and everything else, right? So this framework can be applied whatever platform that you choose to do. But you could deploy this on cloud, any of the cloud solutions, because a lot of these solutions are containerized. You could also run it on-prem if you needed to. But the key thing is that once you've actually got the the solution, right, I mean, there's a whole bunch of the tech stack contains everything that you need to work to run your AI workload. So it's got things like graph AI, tools and components to run complex image analysis and video analysis. It's got like explainable AI, causal discovery, AI ethics built into it, so that you can actually look for things like bias in your data. So it's got a whole bunch of tools and components that you can use to get started right away. And these tools and components are all kind of like pieced together through OSS software or third-party technologies, or a lot of Fujitsu homegrown technology as well. So for someone who wants to get started, they can get started right away. But more importantly, one of the key things that I actually call out is that we've built a whole bunch of business components that these frameworks come with a whole bunch of business components pre-built in it. So these are pre-trained model that follow that meet a specific business case. So take the product defect inspection, for example. What it actually does is it uses image analysis, and we train the model to make sure that it can look for any defects that are there that comes out of the production line, right? So there are also a whole bunch of other business components. I mean, one of the ones that I'll actually call out is consumer behavior analysis. Now, this is used in the retail space. So what it does, it's got a whole bunch of pre-trained models and everything else. So as customers come into the retail store and they make their way through, it can start to look at their foot traffic. It can look to see where people are reaching out, grabbing things off the shelf. If they're putting things back, you can actually start to collect all those kind of analytics and information based on the models that we've actually created, right? So it looks for these specific behaviors and records these behaviors. Now, if you want to kind of like build on top of this and you want to train it for additional things, then obviously you can build on top of these models. So you can actually do additional training and things like that, right? Another business component that I'll call out is the suspicious behavior detection, right? Think of a scenario where you have, you're looking for any suspicious behavior. This is like public safety. So let's say you're in a stadium or a train station or an airport, you want to start looking for any suspicious behavior, people leaving behind bags, for instance, or people loitering, people getting into a fight, trying to break into a car or trying to break into a house or into a door, being where they're not supposed to be. The suspicious behavior detection component will already have a lot of these things pre-configured in it. Obviously, you may want to look for additional things as depending on the business case and things like that, but you can actually build on what's already existing, right? The other beauty about this is, like, you may say, hey, like, what about completely different use cases, right? And that's perfectly fine. So in those scenarios, you kind of like step down to the level below and start using the tech stack that's already available and start training on it, right? So that's how you kind of like start with a pre-integrated AI framework, and you can actually get started and be productive very, very quickly. Now, that addresses, probably one of the challenges that we have, but the shortage of AI talent has still not been resolved. This is a study by McKinsey that was done. This was released in December last year, so it's fairly fresh. I don't think any of these numbers would have changed in the last 8 months or so. You see that a lot of companies struggle with hiring good AI people. So it says that difficult, somewhat difficult, and very difficult. That is a staggering number. So the dark blue and this kind of like the light blue in the chart over there, right? You look at things like software engineers with AI experience, 65% difficulty. You look at something like data architects, that is like a 72% where so it is becoming very, very difficult to hire people. And one of the reasons for the stagnation, I believe that one of the reasons for the stagnation of number of AI application cases is due to the shortage of AI talent. So how do we fix this? Enter AutoML. And this is the cue for you, Peter, to start talking about AutoML.
Cool, thanks, Mahesh. So AutoML was one of the components on that pre-integrated platform that Mahesh just mentioned. So this is a slide from McKinsey in 2020. It's still relevant today. And essentially, something you'll be all familiar with is the fact that a large proportion of a data scientist's time, up to 80%, is spent on understanding and preparing the data. And I'm sure that you're all very familiar with the cliche of spending the remaining 20% of your time complaining about all the understanding and preparation as well. So a common refrain is that only a relatively small proportion of the overall time is spent doing the data science things like developing, testing, and tuning the model code. And what this slide does here is it illustrates how AutoML can automate a lot of the responsibility that the data scientists have of data prep, modeling, tuning, evaluation, reducing the dependency on a skilled data scientist. And in this example, I guess the key call out is McKinsey think it can reduce it by a factor of 4, which is pretty interesting. So the data science workflow in the slide there, business understanding, data prep, modeling, evaluation, deployment, that's the CRISP DM methodology that I mentioned in one of the previous slides on TDSP. So that's where we think we can save effort with AutoML. AutoML provides, I guess another additional thing is that AutoML provides business experts, the SMEs, the subject matter experts in the business, accessibility to the data science tools. So that bridges the gap between business intelligence and complex modeling tasks. And while these tools don't automate everything, they're currently able to produce machine learning models that are very effective and perform well enough to deliver returns. There are many perfectly serviceable AutoML generated models currently running in production across a variety of industries. In fact, the McKinsey report in the URL listed there gives an example of one North American retailer who retrained several hundred employees in its business intelligence unit to use an off-the-shelf AutoML tool to perform customer segmentation. It was previously carried out by highly trained data scientists, but this initiative enabled the company to fill the talent gap between basic BI and very complex ML modeling, and it saved them hundreds of thousands of dollars in data prep. But AutoML is best suited to simple forecasting tasks or where the data is structured and simple metrics are involved. More complex models still require a trained data scientist expertise, so I am not yet obsolete. But I do use AutoML to provide a guide myself as to which technique would offer the greatest performance on a given set of data with its inherent characteristics. So thanks, Mahesh.
Yep. I think I'm not sure whether the slides switched over yet.
Yep, I've got it. So I guess AutoML offers significant advantages and disadvantages. So just to run through them briefly, time and resource efficiency. So AutoML, as discussed, automates the time-consuming and iterative process of selecting algorithms, data prep, and tuning hyperparameters and such like, which can significantly reduce the time and resources to develop an effective ML model. I guess more importantly, it provides that accessibility to non-experts to allow individuals with limited ML experience to build and deploy models. And this democratizes machine learning by enabling these SMEs to create them without needing the expertise of a data scientist. It allows the exploration of multiple approaches. So that's ensemble modeling. A lot of AutoML tie different models together. But as you'll see, that's often at the expense of interpretability by chaining them together. And also it reduces human bias by relying on systematic optimization techniques rather than human intuition. The disadvantages is the fact that it's not so easy to customize them. They're designed to be user-friendly, which can lead to limited options in tuning them. The interpretability I just mentioned, these are black box models. Often if you get some kind of complex random forest or decision tree, you will lose that interpretability that you might have through a simpler polynomial fit or something like that. There are data limitations. So the AutoML's performance relies heavily on the quality and quantity of the training data available. If it's noisy or incomplete, it will need pre-processing and it might not be able to overcome them. And then overfitting, of course, is AutoML naturally prioritizes model performance at the expense of generalization. So it can result in overfitting for your validation data set. And finally, vendor lock-in. So some AutoML platforms may tie the user to a specific ecosystem, making it challenging to switch. Thanks, Mahesh.
Thanks, Peter. Look, we've also got thought we'll kind of like highlight a couple of existing use cases within the industry where they've used AutoML. So we talk about reality or pipe dream. Look, it's not a pipe dream. It is happening right now. People who are tapping into it. We've got 3 examples pretty much picked up from the public domain. One is California Design Den, relatively new brand of for bed linens, and they expanded into the e-commerce world. Like by leveraging AutoML, they have now been able to reduce the inventory carryovers by 50%, which is a staggering number. G5 is another example. So they're in the business of real estate customer acquisition. And one of the things that they were actually doing was, a lot of their salespeople get leads and they need to call them up to follow up on these leads. And they found that they had a success rate of 1 in 7, like 14% or something, right? So, and the morale of these people was very, very low because of the low success rate, and the job turnover was pretty high. So with AutoML, what they were able to do is they were able to precisely identify the high value leads with about 95% accuracy. And it reduced the agent's time by about 80%. So that was like another really great use of AutoML to actually get a business outcome. The last one example I had is Lenovo in Brazil, where they've used AutoML to predict like sellout volumes. Basically, that helps them, planning for inventory, so they don't they don't have too much or too little, and so on. So that's an example of real life examples. So it's not a pipe dream, like I said earlier. These people are already starting to use AutoML in production. Now, it's not always about AutoML. I think one of the key things that I wanted to point out was that I spoke about the pre-configured AI component before. Now, AutoML is just one of several components that are there, right? You can tap into all the other components, like things like AI ethics, right, for bias mitigation. They don't really solve their problems with resourcing like AutoML does, but I think it does accelerate your deployment, really well. Just to kind of like wrap up, I just want to kind of like give you the key takeaways from this session. One is I think you need to focus on solving real world problems, not test technology. I think AI, ML, and they've been around for a while. So if you're doing a proof of concept, go with the real world problem to try and solve it rather than test that rather than the technology itself. The second key takeaway I've got is that you got to plan your initiatives that provide business value with measurable outcomes. So you need to make sure that when you set your AI, get your metrics out, the KPIs and your goals and everything else properly documented so that before you get on with your AI initiative. The third one is around to speed up your delivery times, which is one of the challenges that I mentioned earlier, is to tap into those pre-integrated AI frameworks. The example that we actually gave you is one of them. And the last one is around tapping into the likes of AutoML to account for skill shortages, particularly in the data science area. That's all I had. Thanks for your time, and any questions, please put that in the chat window, and we'll be able to answer on the question section.
There is the question. There's two questions actually.
Okay, can't see them.
Can AI be used in medical? Asked by Anubha.
Sorry, what was the question?
Can AI be used in medical? Maybe in,
Does AI have medical applications? Is that the question?
Yeah, maybe that's what's what was meant.
Absolutely. So I can speak to a couple of use cases that I've worked on myself. We've looked at readmission at hospitals, for example. So when a patient is admitted for a particular ailment, they are treated, and then however the treatment goes, there are records kept about them, and then they are let go out of the hospital. And then what a big problem for insurers and hospitals is whether they are readmitted for a complication or the same issue. And this is a big cost to the insurance companies, a big cost to the hospitals, of course. And of course, it's naturally a huge problem for the patients. So we've had a use case with Victoria's largest private hospital here, looking into that, and we developed a machine learning model using various AI techniques to look at the probability of readmission and to try and triage it at source. So when a patient is admitted for the first time, we can look at indicators like comorbidity indexes, the demographic, the age, the gender, etc., etc. So all of that we can look at triage, and then we can also look at the data afterwards and find out the reasons, further information about what they were treated for, what the SRG codes, what the DRG codes were, how many wards they visited, who were the attending physicians, and things like that. And we can do some historical analysis of that data later. And there's many other AI applications across Fujitsu that I could mention. Mahesh, do you want to jump in?
No, look, I was going to just mention one of them, which is being able to detect brain aneurysms from scans. It's one of the projects that we actually worked on. Pretty cool. I can actually imagine when the scans are being generated, right? You look through it, use AI to look for brain aneurysms. So that's another cool one to talk about. Yeah.
And another one is ophthalmology, looking at the back of the eye, identifying things like diabetic retinopathy. Huge application of AI in that area.
Thanks, everyone.
Thank you, everyone. Bye-bye.